Hey guys, today is the day 10 of the 28 days data science AI and Gen AI challenge. So today I'm going to talk about neural network again. So technically yesterday I have spoken about neural network. It was a very quick introduction about neural network. So today I'm going to give some time on activation. But before I talk about activation, think about a model which is able to predict the stock prices, which is able to do things very similar to your brain, which is able to learn new data, which is able to do something which is learns from its mistakes. So that is what neural network does. But in to do that, activation function is very important. So today I'm going to talk about activation function. In that, I'm going to talk about give some importance to ReLU and Sigmoid. But why ReLU and Sigmoid? I'll talk more about it as we go ahead. Okay. So very quick recap on the neural network. So we know that neural network consists of input layer, a hidden layer, output layer. So this is a very simple neural network, what you can see here, something what we have created yesterday. So which consists of just one hidden layer, one input layer, and one output layer. But when we think about a simple neural network, right, it would be very easy for him to differentiate two classes. Very easy to differentiate two classes. But when it comes to very complex one, where it has to differentiate non-linearity kind of stuff, at that point of time it becomes very difficult for that to do. Then hence we need to have something very complex of more than one hidden layer. But when we use more than one hidden layer, it's very important that it would consist of something called activation function. So activation function, very quickly coming to the next slide. So activation function technically applies to non-linear kind of transformation to the output of the neuron. If you see here, so these are nothing but the weight, the input multiplied with the weight, and when we do the aggregation around it, so it would, if you do something similar to this, it would just go ahead and do good job for linear transformations. But if you want to do something better for non-linear kind of transformation, it's very important activation function has to be put forward, kind of this, okay, which allows then our network to work on more complex models, more non-linear kind of relationship can be understood. Okay, so this can be a very good example of it. So basically it consists of the input layer, the aggregation of the all the weights and the input fields and then we have an activation function, and then it gives an output. Always remember that in a neural network consists of a backward loop, which is also called as a backward propagation. This is very important. If you have seen my code yesterday, it had a backward propagation too. Today I'm going to do a similar code, but much more detailed, much more defined by using the Keras libraries. In that, you will be able to understand very nicely what exactly is happening. Okay, so this is the activation function. Now, in that also, what I have done, I have given some importance to two activation function called ReLU and Sigmoid. Now, when we think about activation function, right, it's very important, as we already understood about it. But why ReLU? Technically, ReLU can be understood that it is abbreviation called rectified linear unit. Okay, so when it has a negative kind of input, it directly gives out 0. Can you see? When it has a negative kind of input, it directly gives you 0. On the other hand, if it has any kind of positive, then it keeps the input and takes it ahead of it. And because of this kind of stuff, right, it learns fast and very efficient. But what happens in other side? So as per the advantages also, because it does very simple kind of stuff, so computationally it is very efficient, it reduces the vanishing gradient problem. So is something called vanishing gradient problem is very interesting to understand, which I'm going to explain you in the next day challenge. Okay, so standard is the standard is this kind of standard is most important in the learning model, so it is widely used. In sigmoid, on the other hand, this is the function of the sigmoid. Okay, sigmoid on the other hand does something very differently. So technically the function transforms any input into value between 0 and 1. Okay, so it is like a probability generator, making it a great thing for classification model statements. Okay, as you can see, when we are thinking about some kind of non-linear kind of transformation, you can think about this kind of functions can be very, very helpful. So what I've done is that when I'm putting forward the code, I have technically used both ReLU and Sigmoid. You will understand that when I have used ReLU in my input layer and my hidden layers. But when it comes to the output, because my output can be 0 and 1, when the outputs are something like that, a 0 and 1 kind of stuff, at that point of time you can use Sigmoid. Okay, it's very, very good. With Sigmoid, try to understand this is not the end of the activation function. There are multiple activation functions. For example, there's leaky ReLU, there's softmax. So as we go ahead, I'll talk more about when to use what kind of activation functions. Okay, but as a start, I think so ReLU and Sigmoid are best to start and best to understand activation functions. Okay, so going ahead, as I've already shared, so it does a very good job in smoothing the gradient. As I've shared, I can talk more about it in the next day challenge. Okay, it is very ideal for binary kind of classification, as I've shared you, like I'm going to show you in the problem statement also. Okay, the output value represents probabilities, so I'm putting forward that also in the code. Okay, so once you are here, it means that you have understand the very quick recap on the what is input layer, hidden layer, and output layer. Okay, always remember that there is always a forward propagation which happens, which calculates the weights and the inputs at the same time. Once you have multiple hidden layer, then you would have an activation function, then it would understand its error also, and then something called a backward propagation happens. So input, hidden, output, forward propagation, backward propagation. If you understand all these functions, then it's then you are in a very good state. At the same time, understand the importance of activation function also. Okay. So next time we are going to, I'm going to show you the code right now. Try to put forward some kind of real world problem statement and try to implement this activation function of ReLU and Sigmoid. Okay. And of course, explore more and try to put forward yourself, have that curiosity to try to get more and more concept, try to put forward new concept and all. If you have any kind of questions, please do comment, and if you like my stuff, please do follow. Okay, I'll see you in the code side. Thank you. Of the neural network activation function by using ReLU and Sigmoid. So as I've shared, the first line talks about the Discord server. If you have any kind of comment, you can come join the Discord server, and I'm happy to answer your questions, comments, and all. I've put forward the GitHub link. I'm going to share the PDF as well as the slides in the GitHub, and the YouTube link is here, which is I'm going to record and I'm going to post it in the YouTube stuff. Okay. So what I have done, I've done something similar, put forward all the things in different cell with a given proper title so that you understand what's going on. The first cell talks about all the important libraries. The only change what I have done is I have used Keras instead of the library which I have used last time. Okay, the torch library. I've not used the torch. I've used Keras this time. I'm going to use a data set of heart disease, okay, where I'm going to talk about how to identify the heart disease. At the same time, I've done all the required thing what I have done every time, for example the train test, split and all. So here, very important, building the neural network. So you can see I have built the neural network. The input shape is 30, so I would have an input layer of 13 neurons. Then I have two hidden layers of 8 neurons. Okay, the output layer has only one neuron, which is going to give me output yes or no, the person is going to have a heart disease or not. Okay, so always remember, because of my backward propagation, right, I have to do some kind of learning. So how the learning is going to happen? So it is going to check my matrix called accuracy. So if my accuracy is improving or not, based on that, it would keep on doing this loop again and again, trying to make sure that I have a better learning, a better output at the end. I've fit the model. I've chosen epoch of 1000. If you want, you can go with a smaller epoch also. I'll tell you the reason later. Okay, I've put forward my train test loss, evaluated the model, did my predictions, and when I visualized it, I can see that my accuracy score has jumped up from 0 to 1 instantly. I don't have to wait till 1,000 epochs. Okay, at the same time, my loss also has reduced instantly from the initial epoch itself. Reason behind that is because I have chosen two hidden layers. My outputs were very linearly distinguishable. That's why I don't need such a heavy neural network to predict this. But in case in tomorrow, if you have some non-linear kind of transformations, at that point of time, you have to have multiple hidden layers, good activation function like ReLU, so that you can put forward your best foot and do a better job. Okay, so this is what we have right now. Okay, if you have any questions, please do comment, and I'm happy to share you my feedback on that. Okay, thank you. If you have reached till here, it means that you have finished the video. Thanks for watching and being part of the 28 Data Science Challenge. Your support, engagement, and enthusiasm make this journey even more exciting for me. If you found this valuable, drop a comment, share your insight, and tag a friend who should join us. Let's keep learning, building, and growing together in the AI engine airspace. Make sure to like, subscribe, and stay tuned for the next challenging stuff what is going to come tomorrow, because we have just started and it's going to get better and better as we go. Bye.